video clip, we want to do two questions. First one is use the properties of determinants to find the value of the second determinant, given the value of the first. For example, here we are given this determinant, and we know the value of this one is 43. Here the first row is XYZ, the second row is UVW, the third one is 1 to -4. We are given the determinant of this matrix is 43. And you can see here the second row is the same. The first row here is the third row, and the third row here is the first row. Basically, they exchange the two rows. Here is the property for determinants. This property says that exchange any two rows or any two columns, the sign of the determinant will change. You see here, exchange row 1 and row 3, you will get a new one. So that's why you want to switch the sign 43 positive to -43. That will be the answer. Very easy. Why this is the case? Here is not a proof, but it is an example. You see, here this is the very simple determinant of a 2 by 2 matrix. 2 row, 2 column. When we do the determinant, we know is 1 times 4 subtract 3 times 2, 3 times 2, which is 4 minus 6, which is -2. If you exchange these two rows, row 2 goes to row 1, row 1 goes to row 2, you do 3 times 2, subtract 1 times 4. So that's 6 minus 4 is 2. So those two are opposite numbers. Okay, so that's why exchange any two rows or any two columns, the sign will be changed. Okay, that's one property. Another one, this is the property. If you have a determinant, let's say A, B, C, D, the determinant of this matrix is M. If you have a constant K times first row, Ka, Kb, and if you have a determinant here is M, then basically you do is pull K out and then use K times M. That will be the answer. Okay, so basically you can take this K out here, and inside is A, B, C, D. So you can find out the determinant of this one. If you are given this one, then times the constant. That's it. Okay, again, the way to illustrate this, here is AB minus AD minus BC is M. Here you do is Ka times D, right here, subtract C times Kb, C times Kb. You pull K out, that's here, and then you have AD minus BC. Okay, you have AD minus BC. Okay, and AD minus BC was M. So you then have M, so K times M, and M is this value, determinant of this one. So that's how we got that. That's a general proof for 2 by 2, but it applies to 3 by 3, 4 by 4, mathematically, when you go to the linear algebra, they have a formal proof over there. Okay, now here we are given the determinant of this one is 40. XYZ, UEW, second row, 1, 2, 3, third row. The determinant is 40. So we want to calculate this one. First, we know there is a factor 3 here. 3 times 1 is 3. 3 times 2 is 6. And 9 is 3 times 3. Based on the property, if here is k, here is k, you pull it out. So we can take 3 out. And we are going to find out the determinant of this one. Okay. Let's see how actually we got this one from here. Look. Here is the constant on row 2. Here is the constant on row 3. So if we exchange those, then we'll switch the sign. Okay, so leave the first row UEW alone. When you switch row 2 and row 3, exchange those two rows, positive 3 goes to negative 3. So that's how you have X, Y, Z. Here is on the second, here is on the third, and 1, 2, 3 goes down to the third. Okay, because we know the third one is constant. Now we are close because the row 1, row 2 is here, row 2, row 1. So if we exchange those two rows, this negative switch back to positive. And then X, Y, Z goes upstairs. Downstairs, second row is UVW. 1, 2, 3. But we know this one is what? This one is 40. XYZ, UVW, XYZ, UVW, and then 1, 2, 3 here. This is exactly the one we have here. So that will be 3 times 40, which gives us 120. Okay? All right. I'll see you next time.